5 grams of copper reacts with excess. That means more than enough silver nitrate. We're not given the equation, so let's start with that. Copper is a metal, and that's going to react with silver is a I'm pretty sure that they mean this is in solution. Okay, so silver nitrate. Oops. All right, one positive on the cation for silver and one negative for the polyatomic nitrate. So they're going to cancel out in this. Let's just say this is in solution. Single replacement reaction. Silver is way at the bottom of the periodic table. Those are in the middle and the bottom. They're generally inert. Right. So these are gonna switch. Cations are gonna switch. Oh, it tells us that anyway. All right, silver is gonna get displaced, and it's gonna be copper nitrate. Does it tell us copper 2 nitrate? So we're gonna need a parentheses here because there's gonna be 2 nitrates because of the 2 positive charge crisscrossing. And nitrate has a 1 negative charge, and we're not gonna write. We don't write ones. All right, and let's say this is in solution as well. Let's balance this. Balance. Coppers are balanced, silvers are balanced. All right, nitrate, we need a 2 here because there's 2 on the product side. And then that's going to unbalance the silver, so we'll need a 2 there as well. All right, so coefficients are 1, 2, 2, 1. Now we can do the stoichiometry. What is the theoretical yield? So that's what we would normally calculate anyway. So we're asked about this silver in this reaction. All right, let's start with that. All right, so we're given a starting point of 5 grams of copper. So we're given the mass of copper, and we're asked to find the mass of silver. It could have been moles, but they're inferring mass, I'm sure. All right, so that's a stoichiometry problem where give you quantities of one substance and ask for you to solve for the quantities of a different substance. All right, we're going to start with what we're given. It's 5.00 grams of copper. All right, and the first step is if it's not in moles, we're going to convert that to moles. All right, so we'll use our periodic table. I have it up here for you. Copper is right there. All right, so we'll use since our answer needs 3 sig figs, all right, we'll use 4 digits there. So 63.55. That's how many grams of copper are in 1 mole of copper. So these conversion factors are equal, so they're valid. All right, we can cross these units out because they're top and bottom. Sorry, not crossing the 5 out, just the units. Second step is where we're going to convert moles of the given substance, which is copper, and get the moles of the desired substance, which is silver. All right, so we're going to use our mole ratios, the coefficients, and I believe that was 2 to 1 in our balanced equation. All right, it's a 2 to 1 ratio, mole ratio. So that's how they're equal. Conversion factor. All right. So now we can, third and final step, we can convert the desired substance. Now that we have the desired substance, is we can convert that into the desired unit. And so let's convert that to grams. Now, if the problem is asking for moles, we wouldn't have to do this last step. All right, so silver on your periodic table is right below copper. All right, again, let's use 4 digits, 107.9. Let's use 107.9 grams of silver in 1 mole of silver. All right, units cancel out because they're top and bottom. All right. Get my calculator out. 5 divided by 63.55 times 2 times 107.9. 16.978. We need 3 digits, so that's just going to be 17.0 grams of silver. That's our answer to the first part of the question. And what is the actual yield if the percent yield is 80%? All right, 80% yield. All right, so percent yield is the actual produced over the theoretical, which is what we calculated. So this is theoretical. All right, we get that by using the limiting reagent, which was given. All right, and then times 100 to turn that into a percent. So let's plug these numbers in. All right, we calculated the theoretical to be 17.0 grams of silver, and we're looking for the accepted. They gave it the percent yield of 80.0%. Let's just double check. Yep. All right, we're solving for A. Just use your algebra. You could do this a few ways. I'm going to get rid of this percent by moving the decimal over twice. Okay, so the accepted value is going to be 17.0 times 0.800. No, I'm going to use a stored number in my calculator because it's actually still there. Times 0.8. All right, so the answer to the second part is 13.6 grams of silver was actually produced. We could have gotten, if everything was perfect, 17 grams, but we actually only produced 13. That's pretty, that's not uncommon. Right? Rarely do you get 100% yield.